Hi everyone, this is Zach. In this video lecture, I'll be talking about hierarchical clustering, which is a type 1 method for clustering. So as a reminder, the clustering problem is a task of grouping a set of objects in such a way that objects in the same group are more similar to each other compared to objects in the other groups. So for example, the blue dots tend to be closer to other blue dots than yellow or red dots. So there are quite a few different clustering methods. We'll be talking about hierarchical clustering, which is a type of connectivity method, but there are other methods which you can read about in the Wikipedia page. So if you think about clustering, the first thing we need to do is to measure the distance between two objects. So let's say we are capturing n attributes of each object. So we can represent the object using a vector xi1, xi2, and xin, where I means it's the ith object, and the 1 to n is the kind of jth variable that we're measuring for that object. So the most popular distance metric, which we'll be using in this course, is the so-called Euclidean distance. So basically, you take the difference of each dimension, you square it, you sum it, and then you take the square root. So this is somewhat similar to the kind of Pythagoras theorem when you calculate the distance, or you can think of it also as the kind of regular straight line distance. If you draw a straight line from I to j and calculate the distance, and you walk across the straight line, that's how you do it. I wanted to mention that there are other distance metrics like the Manhattan distance or the maximum coordinate distance, which you can read about on your own if you're interested. When it comes to measuring the distance between two clusters, there are different ways to do it. For example, one way to do it might be to measure the minimum distance. So if you measure between the red and the yellow and the red clusters, these two point objects are the closest, so you just measure the distance between these two objects. Or you might use the centroid distance. So the centroid is basically, you can think of it as the average point of that cluster, and then the average point of that cluster, and you calculate the distance between the two. And finally, you can also consider the maximum distance, the pair of points that are furthest apart. Typically, we'll be using the centroid distance. And we'll be using something called Ward's method to calculate the hierarchical clustering. Ward's method is based on something called an objective function, which basically measures how good a grouping is. And the objective function, the basic value, is basically equal to the variance of within each cluster, and you sum up over all clusters. So at each step, Ward's method will merge the pair of clusters that leads to minimal increase in the objective value. And this is roughly the same as a centroid distance type algorithm, which calculates the distances based on the distance between two clusters is the distance between the two centroids. So before you calculate the distances, it's usually a good idea to normalize the variables. And that's because the distance is affected by the scale that you choose for the variables. So for example, if you're measuring, let's say, a person's height, you could use meters or you could use centimeters. So the difference between someone who's 2 meters and 1.9 meters would be 0.1 if the unit is meters, but it would be 10 if the unit is centimeters. And furthermore, when you are calculating distances, some of the variables have completely different units or have different scales. For example, something might have a weight, a thickness, and a price, and all of these units are obviously different. So if you normalize the variables, basically we transform it into a variable where the normalization is done using this transformation where x is mapped into x minus the mean divided by the standard deviation. And so what that does is that after normalization, each variable has mean 0 and standard deviation equals to 1. So every variable is on the same scale, even if originally the units and the scale were different. So how does hierarchical clustering work? You start with each data point in its own cluster, and then at each step you combine the two nearest clusters into a single bigger cluster, and you repeat this process until all of the points are in one cluster. Let's illustrate how this works by looking at a very small example with 5 data points. 1, 2, 3, 4, 5. Once I caught a fish alive. Alright, so first these 2 points are the closest, so we'll combine them into a single cluster and color it. Then the next 2 closest points are 4 and 5, so we'll combine them into a single cluster and draw in single color. Then we combine 1 into the 2, 3 cluster. And finally, we combine everything into a common cluster. To illustrate the hierarchical clustering process or hierarchical relationships, we can use a dendrogram, which is a special type of plot. In a dendrogram, the height of the vertical lines represent the distance between clusters or points. So for example, point 2 and 3 are very close when they get combined into a single cluster. That's why this height is very small. And yeah, let me illustrate it again. So these 2 clusters, 4, 5 and 1, 2, 3, are quite far apart, as you can see by the very long vertical line here. But these 2 clusters, 1 and the 2, 3 cluster, are relatively close. That's why the vertical line is relatively short. When you want to group the objects into the clusters, what you can do is to draw a horizontal line across the dendrogram. And the number of vertical lines that you cross is equal to the number of clusters. For example, the red line crosses 2 vertical lines, so you get 2 clusters, 4, 5, and 1, 2, 3. On the other hand, if you draw this the blue horizontal line, it crosses 3 vertical lines, so you get 3 clusters, 4, 5, 1, and 2, 3. So you might wonder, what is the right number of clusters to select? And well, it depends on the problem domain. For some applications, you want a lot of clusters. For other applications, you only want a few. So it really depends. However, looking at the dendrogram does give you some clues about the right number of clusters to select. So for example, let's consider this kind of rule of thumb or rough guideline. The more your horizontal line can move up or down without hitting any of the horizontal lines of the dendrogram, the better that choice of number of clusters. So for example, the red line is pretty good because you can move a lot up and down before you hit the horizontal lines. Whereas the blue line can only move a little bit up or a little bit down before hitting these horizontal lines. So the red line and 2 clusters is probably a good choice, whereas the blue line and 3 clusters is probably not a good choice. Okay, so to conclude, there are different methods to define the distances between points and the distances between clusters. Hierarchical clustering is a method that basically merges the 2 nearest clusters into a single larger cluster. And we can use a dendrogram to visualize the hierarchical relationships between the points. In terms of deciding what's the right number of clusters, we can use the heights of the vertical lines in the dendrogram and use our domain knowledge to decide what is the right number of clusters. Alright, that's all for this episode. In the next episode, we'll talk about how to I'll be explaining how to use R to perform hierarchical clustering. See you next time. Bye.